two triangles. That's all you need for half the geometry questions in the essay if you know how to use them. Let me be direct. 30, 60, 90 and 45, 45 and 90 are the two special right triangles. Their side ratios never change. Learn them once and geometry gets dramatically faster. Start with 30, 60, 90. The sides scale as x, x root 3, and 2x. The short leg is opposite 30 degrees. The long leg is opposite 60. The hypotenuse is opposite 90. Anchor the right angle where the short leg meets the long leg. That keeps your labels consistent. Why does that pattern exist? The smallest angle is 30, so the shortest side sits opposite it. Double the short leg and you get the hypotenuse. The other leg is root 3 times the short leg. If you scale x, every side scales with it. Keep the ratio, change the size. Quick example. If the short leg is 5, then x is 5. The long leg is 5 root 3, and the hypotenuse is 10. Sanity check. The hypotenuse should be largest, and the short leg smallest. Always opposite angle pairing. Now the second family, 45, 45, 90. The isosceles right triangle that shows up everywhere. Now 45, 45, 90. The sides are x, x, and x root 2. It's an isosceles right triangle. Two equal legs and a 45-degree angle at each base corner. Both legs equal x. That is your fingerprint for a 45, 45, 90 triangle. If a leg is 7, the hypotenuse is 7 root 2, no extra thinking required. The diagonal of a square always creates this triangle. That's why square problems love 45, 45, 90. Sat style. A ladder 12 feet long leans against the wall, making a 60-degree angle with the ground. Sketch the wall vertical, the ground horizontal, and the ladder as the hypotenuse, 60 degrees lives at the ground corner. Model a right triangle. The ladder is the hypotenuse. A 60-degree angle at the ground means 30, 60, 90 ratios apply. 12 equals 2x, so x equals 6. The height is opposite 60 degrees, x root 3, which is 6 root 3, about 10.4 feet. Notice, you did not need to write sine of 60. The ratio did the work. Another classic, the diagonal of a square is 10. Find the side length. In a 45, 45, 90 triangle, hypotenuse x root 2 equals 10. In a square, the diagonal is the hypotenuse of a 45, 45, 90 triangle, not x. So x equals 10 over root 2, which rationalizes to 5 root 2. That is the side. If you leave 10 over root 2, simplify. The answer choices often show the rationalized radical. Side by side, 30, 60, 90 stretches the long leg by a factor of root 3. 45, 45 keeps both legs equal. Squares and diagonals almost always point you to one of these two patterns. Name the triangle before you crunch numbers. Checkpoint. If you can name x in under 10 seconds on a clean diagram, you are ready for harder essay traps. The mistake I see constantly. Mixing up which side goes with which angle in 30, 60, 90. Rule. The smallest angle sits across from the shortest side. 30 degrees is smallest, so the short leg is opposite 30. If you accidentally call the long leg x, every downstream number breaks. SAT pro tip. These ratios appear on the reference sheet, but memorizing them saves 30 seconds or more per question. You can always verify on the reference sheet, but fluency beats tab hunting when the clock is ticking. Whenever you spot 30, 60, or 45 degrees in a diagram, think special triangles first. Speed matters because math is tightly timed. Automatic ratios beat hesitation. Let me compress the whole lesson. 2 triangles, 2 ratio families, 1 habit. Label angles before you label sides. Recap, 30, 60, 90 uses x, x root 3, 2x. 45, 45, 90 uses x, x, x root 2. Watch opposite angle pairing, name the hypotenuse first in setups, and rationalize when needed. Practice until these ratios feel automatic. That's when geometry stops feeling like a scavenger hunt. Drill until the ratios feel boring. Boring is good on test day. Practice more on NovaMaths.